Now I am going to explain you about random variables. So what is a random variable? Randomly selected variable. So it values, random variables means randomly variables. Here we are only taking the values from 1 to n values. So here S is a sample space of a random experiment. A function x assigning a real number x of phi, x of psi for each E belongs to S is called a random variable. Here E is an event. So the set Rx is equal to x of E if from x belongs to S is subset of R. It is a set of all positive values of x and it is called a range of x. Thus one can express x from S to R is a random variable. So after random variable we have a definition of distribution function. It is very important to study other discrete or continuous random variables. If x is a one-dimensional random variable, the function f defined for all the real t by f of t is p of x less than or equal to t is called the distribution function of a random variable x. We have two types of random variables. There are two types of random variable: discrete random variable and continuous random variable. In discrete random variable we are using summation for calculation. A random variable x is called a discrete random variable if its range space Rx is finite or countably infinite. For example, the number of defectives in a sample of n events, the number of accidents per year. For a discrete random variable, we have discrete probability distribution or probability mass function. The definition of a discrete probability or probability mass function is given as: if x is a random variable with its discrete range space Rx is equal to x1, x2 and so on up to xi, p of x1 equal to p of xi, then the collection of xi comma p of xi, I equal to 1 to 3 and so on, is called a probability mass function. The properties of two probability mass function is given as: p of xi is greater than or equal to 0, summation p of xi is equal to 1. So another distribution is known as another random variable. We have continuous random variable. A random variable x is called a continuous random variable if its range space Rx is countable, uncountable or an interval. Interval means here we are using integration. Instead of summation, we are using integration. We have examples of continuous random variable: height, weight, temperature and life periods. So continuous probability distribution or probability density function. For discrete it is probability mass function, for continuous it is probability density function. If x is a continuous random variable with a continuous distribution f of x, a non-negative function is called a probability density function of x. F of x, we are denoting it as f of x. If it is discrete it is p of x. Is integrable on every interval a comma b. Interval we are taking here two properties of continuous probability distributions. Density function is given as f of x is greater than or equal to 0 for all x. Its integral minus infinity to infinity f of x is equal to f of x dx is equal to 1.